we discussed today will be little duplication, and we'll get some topics later. It should be an extension of what I discussed now. Quickly, what is research? Particularly, whatever we are discussing today is all pertaining to social science. What is research? Subjective is meant to give us good knowledge and idea on this very topic of research. What is research, sir?
Undertaking investigation.
Okay.
Whatever we have, something
Adding knowledge to the existing body of knowledge. Okay. Now, research, particularly social science research, essentially is about finding solution to a problem, finding answer to a question, addressing social concerns. Explore and explore for what, sir? Ultimately, whatever we explore should lead to this. Let's see. What are the steps in research? Again, social science research. What's the first step, sir? When you have to carry out research? Identifying the problem. Perfectly right. And this itself is the major challenge. In fact, this is one area we need longer time. Even if you have to take 1 year, 2 years, that's fine, because only when we have a meaningful, appropriate, relevant problem, all the research what we do will be appropriate. So the first step in research is to identify problem. How to identify problem? Okay. Now, since we're talking about academic research, I just would like to focus on that. But yeah, problems are available in and around us. Everything that we look at, there's a problem, and there can always be a solution for it. Finding that is research, no doubt. But keeping in mind academic research, which helps us to get a qualification like PhD, talking about academic research, how to identify problem? We do that by carrying out something called literature review. And by doing this literature review, we identify something called research gap, and that gap is what leads us to problem. Now, how to identify this gap, how to do literature review itself is a very large area. Normally, we do one-day workshop on how to do literature review. Time permits, I'll try to give some insights, but that's not the topic today, so I'll not get into that right now. But at the end, if time permits, there are certain things which I'll share with you. If I can have some internet connection, I'll show some very simple but very, very effective ways of doing literature review. But step one is to identify problem. And this problem what we identify is also called research motivation. Purpose of the research what we are carrying out. Hence, this is also called the why aspect of research. So why we are doing so-and-so research to address so-and-so problem. So this first step, research problem, is called why aspect of research. What's the second step, sir? Any idea? All of us here for purpose. So it will be good if you can keep aside our mobiles. Already we are last time. Let there not be further distractions. What's step two, sir? After identifying why this research was the problem we should address, second step is objectives. What are the objectives of the study? What do you mean by objectives? What should we find out in this research to get solution for the problem? I repeat, what all should we find out in our research to get solution for the problem? So this objective is called what aspect of research. So why aspect, research motivation was the problem. What aspect, what we should find to get solution for the problem. How to derive objectives, again, is another very interesting area. All this is something we can do hands-on. Once the problem is ready, what all we need to identify. I'll also show certain things later. Then comes the next stage. Tell me, what next, sir? After the problem, objectives, why and what? What do you think is the next stage in research? Sir? Okay. Now, this is one wrong notion that we have. Hypothesis comes along with objectives. Actually, no. Hypothesis is something which actually emerges at the time of data analysis, which I'll show you. Now, while writing the thesis with objective, we write hypothesis. But in reality, it's not something we derive, we make at the time of making objectives. No, it is something which happens in a different mode. which I'll demonstrate today. Now, after objectives, what we should find? Why, what exactly? It is called the how aspect of research. How to find what we wanted to find. Let's keep in mind. Why? Problem. To get that problem, what all should, to answer the problem, what all should we find? Objectives. How to find that? That is methodology. So what do we do for that? Though there is a lot of components under methodology, one thing we do is design the tool. Design the tool, which is questionnaire, schedule, whatever. So yesterday I think you had one session, measurement and scaling techniques, etc. So something which you can keep in mind to design the tool. So we design the tool, that is make the questionnaire or schedule, whatever. Then identify from whom to collect the data, whom we call respondents. And there we make a lot of decisions. Is it census survey, sample survey? If it is sample, what should be the sample size? How to identify the sample? I think yesterday or tomorrow, I think you have one session on sampling, etc. So we make a lot of decisions. But once the tool is ready, after all these decisions, from whom to get the data, that is the first step. Purpose of the study, need for the study, statement of problem, all that is step one. For that purpose, what else should we find? To meet that purpose, that is objectives. So objective is what you should find. What are those findings? What we found for the objectives. So findings is something. Conclusion, which is answer for the religiously follow the process to see how we can do research. And once you get used to doing research, you can speed it up. Normally what we take 2 or 3 years for doing PhD, definitely later you can cut down research for 1 year, 6 months, for sure you can do. But getting exposure and following the process is very nice. Let me show 2 things now. Let's say problem is ready. From problem, what should we derive, sir? Objectives. Based on objectives, what should we design? A tool, which is where schedule the questionnaire. How to design that? Okay, just show. Take a look at this and let's discuss together instead of discussion between. Companies conduct training to their employees, and what a company wants to happen, this training should be effective. That's the purpose of training is much. But how to find out the training what company with employees is effective or not? There are many tools, many techniques available to assess, to evaluate effectiveness of training program. One such tool is called return on investment. This was a study about that. How good that tool is. No, that is not perfect. No. Like in any problem, First stage, statement of problem. As a second stage, second step, objectives. First step number 3, sir, tool. From this objective, what should be designed? Tool, questionnaire, or schedule, whatever. How? Please see what I show you. And what I am showing you is what leads us to topic of discussion. What do you mean by objectives? Sir, don't you have any other alternative, sir? Already we are losing time. Okay. Okay. It's okay, sir. Now I'll mention it. Okay, fine. Okay. Now, how to design the tool? Each objective, what are objectives? What we should find to get solution for the problem. For each objective, we should identify to ascertain, and we know objective are action points, action oriented. That's why all objectives begin with to ascertain, to find, to evaluate, to assess, etc., etc. So, to find this, what are data points we need? What are data points we need? We list out. And if it's your area of research, I'm sure for the requirement, for what we should find, what are all the data points? Definitely you would know, and that is one of the requirements. Unless you have done thorough literature review in your own domain, you should not obviously begin with research. So, whatever your area, the background would have been known to you. Unless known to you, you can't start research. And for each objective, what are the data points we should identify? So, here objective 1, whatever, to ascertain whatever, these were the data points. Same way, objective 2, objective 3, identify the data points, friends. This is what we need to collect. This is what we need to seek from whom we call respondents, and if we can get this, our objectives are met. Now, this data points, using this we design the questionnaire. Normally what we do, look at all the data points, it may be 100 points, 50, whatever. Whatever is duplication, remove that. Then sequence it in the required order, your questionnaire or tool is ready. But once the tool is ready, collect the data, then comes the most important stage, data analysis. And most research, this is what I always see, people begin research with lot of enthusiasm. I keep saying this, whenever I meet any research scholar, ask them, what's the progress in your research? They say data analysis, I'm doing analysis. 6 months later, when I ask them what is the status, they say, I'm still in analysis. 1 year later, they're still in analysis. This is called paralysis of analysis. They get paralyzed in that stage. And reason is that most research scholars don't know how to do analysis. Trust me, very simple. As I said, very systematic. There's no question of going wrong if you know what. These data points, whatever we have, or the data which we can, the questionnaire, we should classify them for analysis into different types. One, primary data, secondary data, which all of us know the difference. What is secondary data, sir? It's already existing somewhere, which you just obtain. So that's not what we need. What is primary? Not available in that, what you need to identify is what you need to have. That is what should be identified. More importantly, whatever the data that we get, the two more classification we should make. If not, we can't go this into Assume yesterday it was discussed. All the data, whatever we have, should be classified into, is it nominal data, ordinal data, interval data, ratio data. I guess yesterday measurement was discussed. So very quickly, if you can. What is nominal data, sir? Data which enables classification of responses into different groups. So no one group is different from other. Gender, male and female. So it's a classification. All responses to male and female, but male, female, nobody is different from. Nobody is superior, nobody is inferior. Occupation. Type of mobile brand used. Mobile brand, I use Samsung, we use OnePlus, etc. Into based on how we use our mobile phone, what data mobile phone. Can we say this group is better than this group? So nominal data is such data which enables classifying a response in different groups. No one group is different from other. Hair color, complexion, all those are black hair, all those are brown hair, green hair, grey hair. But any one of them is superior or inferior to this? This is nominal. What's the second type, sir? Ordinal data. So what can be the example? Result. Exam results. Fail, first class, second class, first class. Educational qualification. What is educational qualification, sir? Schooling, graduation, post-graduation, or doctorate. Now, what's the here also? Here also, all respondents are classified into different groups, but one group is either higher or lower than the other group. So all those who are postgraduate are higher than graduates, lower than those PhD. So even ordinary data is a type of data. So what is ordinal data? It enables classification of response into different groups. But here, one group is different from other. So both nominal data, ordinal data. What is it? What is it about? It's about is nominal, ordinal, and both these nominal and ordinal together are called categorical data. Both these is called categorical data. Third type is interval data. Interval. Any example for interval data, sir? Temperature is generally mentioned as an example, but honestly not very appropriate. Time at which you arrived in this class. graduation, time of completing the exam. Now, year of birth, let's say 1971, 1976, 2005. Period of time, but time at which you arrived into this class, time. But why it's called interval is difference between the two items as a meaning. Let's say date of birth of one is 1971, other one is 1999. Difference is how much? 28. So we can say this person is born 28 years earlier than this person. This person is born 28 years after this person. Let's say I came at 9:45, you came at 10 o'clock. Difference has a meaning. What is it? This person came 15 minutes after this person. This person came 15 minutes before this. So where difference as a meaning, we call such data as interval data. And obviously all this is numerical, quantitative. Nominal, ordinal, not quantitative, it's not numbers, but interval ratio data are quantitative. But why is it called interval data? Difference as a meaning. And for ratio data, now, what's the example? Age, income, height. Let's say my income is 1 lakh, your income is 2 lakh. Ratio means what, sir? When you divide, we call it as ratio, correct? So let's say 2 lakh by 1 lakh, that quotient has a meaning. Your income is twice my income. My income is half your income. I am 50 years old, let's say you are 20 years old. So when you divide 50 by 20 or 20 by 50, quotient has a meaning. Such data we call as ratio data. Now both these are numerical, but where the difference has a meaning, it is interval data. When you divide, if it has a meaning, it is ratio data, and both these together is called scale data. Both these are called scale data. Now this is one information we need to get into analysis. How is it all connected with hypothesis? You will see in just a few more minutes. One more classification of data. So we have identified the problem, derived the objectives, designed the tool. I just gave a brief overview of how to design the tool. Data points, have that in your tool. And this data what are collected, before we start the analysis, identify what type of data we have. One, the data, each data point, is it nominal, ordinal, interval, ratio? And two, one more classification, is it cross-sectional data, cross-sectional, time series data, panel data. Particularly, if your research is at the doctoral level, this is a key requirement. No PhD should be less than developing a model. Every work, research work, should ultimately lead to building a model. That building model is called econometrics, and especially if you are doing research at PhD level, that's a requirement. How to do that is the next. Now, all this is part of data analysis. Now, how? What? I'll show you. Now, what is cross-sectional data? Just visualize. Let's say 2022-23. Okay, I'll take a very simple example. Let's say college. This year, what is the admission? So, college A, college B, college C, college D, 100 colleges I take admission for a given year. Cross-sectional data we call it. So, for a given period, if you have data of different respondents, it is cross-section. Let's say I take one college and take last 10 years, what is the admission, number of students admitted. 2011, 12, 12, 13, 13, 14, 14, 15 till 22, 23. Each year, how many students are admitted? What type of data is this? Time series. Across time, we find. Same time, different respondents. What are the data we get is called cross-sectional data. Across time, for one respondent, whatever data we get is called time series data. Now, I'm sure at least all of us know about stock markets. I take yesterday, 31st October, closing price of 100 stocks. Yesterday, last one day, what was the stock price? I take one company, Reliance Industries Limited, and take last 1 year, every day what was the closing price. First one was example of what? Cross-sectional. Second one is example of time series. I take 100 companies and its sales, turnover or profits for 1 year. I take one company and find out what is its profits for last 10 years, 50 years. Cross-sectional, time series. But then if I take 100 companies, 10 years, 100 colleges, last 10 years. When I combine both cross-sectional and time series, what we get is called panel data. So, panel data is a combination of cross-sectional and time series. Now, this is the classification we should be able to identify before we go for data analysis, the fourth stage in research. So, first step, problem identification. Step 2, deriving objectives. Step 3, designing the tool. Step 4, data analysis. As a prelude to data analysis, what we should do from the tool, whatever we have designed, identify every data that we have, what type. Is it nominal, ordinal, interval ratio, and is it cross-sectional, time series, panel data. Now, this is the foundation for the next stage, data analysis. Now, what is all this to do with hypothesis, our theme? You will see in just a few more minutes. Now, how to do data analysis? Friends, whenever I say research, whatever analysis we do is broadly 3 types, and all this has to be carried out, and all this is something to be done in a sequence, one after the other. First, we should do something called descriptive analysis. So, I could see one session on this itself before SPSS hands-on. That I'll give a brief orientation, maybe that session will get even more insights. 2, and most important, inferential analysis. And 3, predictive analysis. Descriptive analysis, inferential, predictive. Now, when I say data analysis, this is what we do. You may not have to know the names, but whatever we do is this. Now, what is descriptive analysis? As the name itself says, analysis is what we do to describe the data, that is it. Describe the data. But this does not add anything to our research. This is just to understand the data, that is all. It has nothing to do, it does not add any value for our research. Anything that adds value is the next one, inferential analysis. I will tell you what. But what is this, how to do this descriptive analysis? Friends, for doing both these analyses, descriptive and inferential, we need the classification of data we need is it nominal, ordinal, interval, ratio. So, based on that classification, this analysis will be done. But to do predictive analysis, we need is it cross-sectional, time series, panel data. So, that is the reason first we should identify, so we know what can be done. Now, what is the descriptive analysis? How to describe the data? Simple. If it is categorical data, what does categorical data include, sir? 2 types. Which are the 2 types? Nominal, ordinal. It is categorical data, like I said, gender, occupation, education, mobile brand, etc., etc. For all these, simple. Either we make tables or charts or diagrams. By making tables or charts or diagrams, we describe the categorical data, how many male, how many female, education qualification, out of respondents, how many in which category, that is all. Now, is it really of any big use for us? It is good to have, but on its own it has no value addition, but still we can have. And if it is scale data, what is scale data, sir? What does it include? Numerical, but this numerical data could either be interval or ratio. Interval data is one where the difference has a meaning, ratio data is one where division has a meaning. Now for this, to describe the data we use mean and standard deviation. Mean and standard deviation. Now usually at undergraduate level, when we make our students do research, this is what we make them do and it stops there, that's it. For UG level this is fine, but this is just the beginning of research. As I said, honestly this doesn't add any value for our research, but we should have it. How it helps further you will see. But now I'll repeat my very first question that I asked. What is research, sir? What is research? What is research? Finding solution to a problem, finding answer to a question, etc. So what are the steps we did? First we identified the problem, derived objectives. For that object, keeping that objective, we designed the tool. From the tool we collected the data. The data we should analyze. From the analysis what do we get? Findings which should match with our objectives, and from that findings we draw conclusion which is solution to the problem. Now how to get that findings? That is what happens with this inferential analysis. So this is the true foundation of research. Now how to do inferential analysis? What do you mean by the word inferencer? Inference? Conclusion. A conclusion is actually very top word, something at the top. Inference is a temporary conclusion, tentative conclusion, what we find. So it is at the lower level, and all these inferences actually will help us in finding the conclusion. So in research, conclusion is solution, inferences is our findings. Now how to find? Remember, objective is what to find. How to find? That we can do with the help of inferential analysis. How? For this, we need certain backgrounds to do this inferential analysis. One background already given, type of data, but another very important, interesting background is something called hypothesis. So inferential analysis begins with, ends with, everything about inferential analysis is about hypothesis. So as a background for this we need two things, I mean many more things, but I am just mentioning two. One is type of data and B, hypothesis. Now type of data already we have discussed, and for inferential analysis the classification we need is the data nominal, ordinal, interval, ratio. You will see how, if having knowledge on that helps us to draw inference. But more interesting is hypothesis. What is hypothesis, sir, in your understanding? Sir, already asleep. Come again, sir. Tentative statement which can be proven or disproven. Okay. Now I am a layman, I didn't understand that. Let's say that's correct. You are right, very right. But something which assumption, wonderful, correct. Assumption is very close term. Possibilities, no. Okay, I'll see. I'll tell you that. Absolutely. That assumption what you make is what actually leads us further. That's right, madam. Now technically it is assumption, but to be more specific it is statistical assumption. To be even more specific, it is statistical presumption. Statistical assumption or statistical presumption. Ma'am, even qualitative there is a statistics involved, but how? Statistics is definitely not only about numbers, there are a lot more beyond that. Okay, I'll come to that just a little later, we'll be diverting from our discussion, we'll come to that. So, in many of the qualitative, we can't actually even make hypothesis, but what we can make, then there also it is statistical assumption only. Now, why should we make assumption first of all? What's the need to make assumption? And since it is an assumption, we should check is it true or false, should we accept or not, etc. later. But it gives a background, correct? It's a direction, okay. But again, as a layman, honestly, I am not understanding these things. You are right, actually all this is absolutely right. Now we make assumption for certain reasons. One, let's say we are collecting data about students in Mysore. Some issue about students. How many hours do they spend in the library, etc. So whatever it could be. How many students are there in Mysore, sir? Okay. Now how many students we have in Mysore? Approximate one number, some lakhs, infinite, lakhs. Do you think we can get data from everyone? Impossible. So normally what we do? Go for a sample. We collect data from sample. So whatever calculation makes, statistics I calculate, mean, whatever it be, is for the sample. But based on that, can I make decision for the population? No. So what we do, whatever result, outcome we got for the sample, we assume about the population based on that. So it's an assumption we make for what? For the population. Let us suppose you collected data from the entire population. There is no need for any hypothesis. So hypothesis emerges because most of the time, and because we collect data from sample. But decision should not be made for the sample, it should be made for the population. So we assume something about the population on the basis of sample, that is this assumption. How to make all that, let us see. That's the focus in the first session. Now this assumption what you have to make about what? Population, based on what? Sample, is broadly two types called null hypothesis. What is another one, sir? Alternate hypothesis. Alternative or alternate hypothesis. So collected the data. I started analyzing the data. For every data that we have, I'll show lot of situations now. Every data that we have, first thing for us to do is make an hypothesis. So inferential analysis begins with making hypothesis for every data point. Every single data that we take, we should make assumption or we should make hypothesis. Because the data what we have is only for the sample, we should actually find solution for the population. So we have to make assumption. But what is this null hypothesis, alternate hypothesis? Once the difference is understood, trust me, you will understand how to make hypothesis. What is this null hypothesis and alternate hypothesis, sir?
So when you assume something after collecting the data, when it is disproven, it becomes
In fact, null hypothesis is what we are testing. In case it is disproven, then we go for alternate hypothesis. But in the name itself, there is something. Now, this is null hypothesis. I am mentioning three statements under this. If you can keep this in mind, you will see for every single scenario that I give you, you can make the hypothesis yourself. One, null hypothesis says there is no significant difference between sample and population. In colloquial terms, we say no difference between sample and population. No difference mathematically is what, sir? Zero. Zero is also called as what? Null. Because it says no difference. But technically it's not no difference, it should be no significant difference. Every word has a meaning. So null hypothesis, what does it say? There is no significant difference between sample and population. This is one scenario. I am mentioning 2, 3. You will know when to use what. There is no significant difference between two groups. There is no significant difference between two groups. This is another category of null hypothesis. Null hypothesis say no difference, to be precise, no significant difference. Because it says no difference, called null hypothesis. This is what we are assuming about the population. And there is a third scenario, third category. There is no significant relationship between two variables. Whatever hypothesis we can make from the data is captured under these three statements which I have given you. So, all that you have to see is from the questionnaire what are the data you collect, see the data and identify which of these friends you are ready with the hypothesis statement. But we will take examples, good number of examples, understand one by one how to make this. But what is the hypothesis? Statistical assumption or presumption about population, or just mention statistical assumption. When we are analyzing the data, inferential analysis, what we should do? For every data point, every, let us say gender, income, savings, whatever, every single item, you should make hypothesis. You should. That is the process of inferential analysis. How? I will show you now. But since it is a hypothesis assumption, what should we do? Test. Is it true or false? What is correct? What can be accepted? That is alternate, and which is exactly opposite of this. What does the first category of null hypothesis say? There is no significant difference. Here, there is a significant difference. But the writing hypothesis, we write it very interestingly. The basic statement. Similarly, there is no significant difference between two groups of null hypothesis. There is a significant difference between. There is no significant relationship. There is a significant. So, data analysis, descriptive, describing the data. Key analysis is inferential analysis. What should we do? Identify for every data what is called hypothesis or null hypothesis. How? We will see. Identify, also identify alternate hypothesis. Once you make the hypothesis, test it. How? I will show that. And what test to use how, and at the end of the test, if null hypothesis is proven true, that is our inference. If null hypothesis is proven false, then what becomes our inference? Alternate hypothesis. But then, as a statement it is fine, but how actually should I write the hypothesis? And this is one area where 90%, trust me, research scholars go wrong. There is some wrong notion that null hypothesis means negative statement. So, any negative statement assumption, they think it is null hypothesis. No. This is what null hypothesis say. How? Let me show some scenarios. This is on the desktop here. or later I'll give my email ID, please mail me. I'll share all these files and whatever else which is required. Now, null hypothesis we denote with H naught, 0 it is, H naught, null, 0. Alternate hypothesis we usually denote with H A, this is the usual denotion. Okay. Now, we have marks data of 100 students from a university. Mind you, in a university, how many students will be there? Thousands. But we collected data of 100 students, and the average of that 100 students, what is the average marks of these 100 students? 68. Now, based on the 68 student marks, based on this 100 marks, 68, can I say all students of the university are above average or first class students, can I say? No, this is only for 100 students. Unless I get to know what is it for the population, can I make decision? So, assume, based on this we make a decision. All students in this university are first class students. So, we don't have to spend much in the library. Students are good. We don't have to give them placement. They can find their own jobs. Can we make such decisions? No, wrong, because this is only for, based on how many students? 100 students. So, what should I do? Based on this, I should make assumption for the entire student, all students of the university, population. Now, tell me, among the 3 statements which I gave you, which one is applicable? First one, what does the first one say, sir? No significant difference between sample and population. So, going by that, this is how we write. The average marks of all students of the university is 68. I am not writing there is no significant difference, correct? There is no significant difference sample and population. But based on that, what is the assumption? Whatever is the average marks for the sample, same is the average marks for. I don't have to write there is no significant difference. Correct, that is the foundation, but that is not what you should write, right? Based on the data, what is the statement? And again, I repeat, somehow people are under the impression, if I write negative statement, it is null hypothesis. No, there is nothing about negative, positive. It's all about the data. It's all about no significant difference. So if there is no difference, whatever is the average we got for the sample, same should be average for the population. So for all students of the university, what is the average marks? 68. Technically, since we are not getting too much into mathematics, I am not mentioning, but just let me show this. Insert symbol. Now, this symbol what I am using is called mu. I think little statistics all of us know. Average, how do we denote? X bar, correct? But X bar is for sample. For population it is called mu. So, technical this is our right. Mu is equal to 68. What does it mean, sir? Population mean is 68. This is sample mean, X bar. So, what is the assumption I am making? Population mean is 68. So, this is another way to write. What's alternate hypothesis? What's alternate hypothesis? There is a significant difference between sample and population. So, the population mean is not equal to 68. Not equal to 68, but there is a small catch here. Not equal to 68. What could not equal to 68 mean? Either it may be less than 68 or greater than 68. Now, how I write depends on certain other data which we don't have here, but it could be not equal to 68 or less than 68, greater than 68. If I say not equal to 68, we call it as two-tailed, less than or greater than for it, one-tailed, some statistical aspects which I am not getting into. This is exactly the reason why it is called statistical assumption. Anyway, equal to, not equal to. So, the marks of the entire university is, average marks is 68, that is the null hypothesis. How to test it? Now, I will come to that just a little later. once we understand how to make hypothesis, how to formulate hypothesis. So hypothesis is not something which we design at the beginning, at the time of objectives. It is something to do with analysis. With every data point, there will be an hypothesis which we should test. And by testing it, we draw the inference. Whatever test we apply for this actually we apply something called independent t-test. I will give the list later. At the end of the test, if the null hypothesis is accepted, when to accept, when to reject, all that I will mention. Null hypothesis is accepted. What is our inference? The average marks of all students of the university is 68. If rejected, what should be the null hypothesis? What should be the inference? Not equal to 68, less than, more than, whatever. So drawing inference is that. Make hypothesis, null and alternate, test it, draw inference. But how to make hypothesis is the first stage what we are learning. Now this was a simple case. Now let us take more cases. Marks of students of two different colleges for the same subject is available. So one subject, two college marks have been taken from students of two colleges. Data was collected from 100 students in each college. So college A, college B, 100 students were taken, marks scored. Average marks of college 1 is 59 and college 2 is 63. Now this is the data we have. So this is the data we have got from our tool. Now what do you think is the inference? We should draw some inference from this. Drawing inference starts with making hypothesis. What hypothesis? Null and alternate. So what is the null hypothesis, sir? Three statements are given under null hypothesis. Which category it comes under? Simple. What is it? So what is it? There is no significant difference between two groups. So here there is no significant difference in performance of two colleges, both the colleges. Performance or result in this subject of two colleges. So, right, there is no significant difference, or the performance of both the colleges are same in the subject. Actually, what is the statement? There is no significant difference between two groups. No significant difference means what? Both are same. In what? In the performance, in the subject. See the basic statement, see the hypothesis. Now, if you want to write, there is no significant difference between two colleges, no problem, write. But end of it, the inference will be this statement. So, whatever is the final inference we have to write, it is ideal that we raise that. But now, what do you think is alternate hypothesis? What does alternate hypothesis say, sir? What does it say? There is a significant difference between two groups. Okay. Now, if there is a difference, what should I find? Who is better than whom, correct? Now, what can I see for that? What's the average marks of college 1? What's the average marks of college 2? Going by that, what do you think, who do you think, which college is better? So what is my alternate hypothesis? College 2 students are better than college 1 in performance. That is alternate hypothesis. So, students of, or college, it simply, college 2 is better than college 1, something like that. Now, from where did I get this? Based on this average, whatever. That's the reason a descriptive analysis, what we make at the beginning, will give us the insight. What should I use for descriptive analysis? Categorical data, tables, charts, diagrams. It is scale data, mean and standard deviation. So, though on its own it doesn't add any value, it is because of that we are able to draw inferences, we are able to make hypotheses. Ma'am. Wonderful. So, what we should first establish for that is what is the ideal sample. Here just an example. Time permits, I will show you a couple of websites how to identify for any this thing what is the ideal sample. So, it should be ideal sample, yes. It can't be just some random number like 100. Average daily production details daily production. Available factory for last 1 year for 5 working days in a week. Something like this. Which are the working days of a week? 5 working days means Monday, Tuesday, Wednesday, Thursday and Friday. Now, last 1 year, they taken average daily production for last this thing. Means how many? Obviously, Mondays will be there, 52 Mondays, 52 Tuesdays, 52 Wednesdays. So, let us say, how is average calculated? So, all the 52 Mondays production total divided by 52. All the Tuesdays, 52 Tuesdays production total divided by 52, etc. So, it is calculated. This example, let us say 100, 110 units average. So, every Monday, what is average production on Mondays? 100 units. What is average production on Wednesdays based on last 1 year data? Something like that. So, Thursday, let us say 115, Friday, let us say 98, something like this. Now, this is the data we have, that is what they say. So, this is the data available with us. So, average daily production details, average production for 5 working days in a week based on last 1 year. So, like this we have data. Any data, do not look at the data and make any decision. Data. The production on Thursdays is higher than other days, lower, etc. So, alternate hypothesis always should be based on the data, but null hypothesis is the foundation for that. Now, if you just write there is a significant difference, no, that is not our inference. Fine, difference is there, okay. What is that? That is our inference. It is here. We do not have to struggle much, but identify that. Opinion was collected from 100 employees regarding place of visit for a Sunday picnic. So where to go for a Sunday picnic? 100 people were asked. 5 places were identified and employees have recorded their preferences. Now, I'll just show this way on Excel. Okay. Friends, let's say this is the place 1, 2, 3, 4, 5. Now 100 employees were asked opinion about which place to go. So employee 1 has given, let's say, first preference for this, second preference for this, third preference for this, fourth preference for this, fifth preference for this, employee 1. Now data has been collected from how many employees? So this is employee 1. Same way, employee 2, let's say, first, second, third, fourth, fifth, something like that, let's say. Friends, after all this is done, what can we find, friends? What can we do? Place 1, 2, 3, 4, 5. How many gave first preference? How many second preference? How many third preference? Fourth preference? Fifth preference, correct? This is how we can arrange the data. Okay. So let's say place 1, 20 gave first preference, 22 gave second preference, 30, 18, 10, something like this. Then second place like this. So the data. This is the data available. How to analyze such type of data is a different story. If you have understood what I explained, somewhere you mentioned something called Garrett ranking. Garrett, Garrett. Data of this type, we use a technique called Garrett ranking type. So please mention. I may not get time to discuss it today, but please make a point to watch, because very common questions, ranking, preferences is very common questions in questionnaires. So the technique we should use for it is ranking, Garrett ranking. But ma'am, Garrett. Garrett. Garrett ranking. Okay. Now this is the data we have. What is the hypothesis? Null hypothesis. Always it is null hypothesis. How many places to visit? 5 places. These are preferences. What's the null hypothesis, sir? No significant difference in preference to all the 5 places. Means all 5 places are equally preferred. Preference is same for all 5 places. That's null hypothesis. Alternate hypothesis? Now we should do analysis, because there is first preference, second preference, etc. So which has got the highest preference, which has got the next highest preference, overall ranking. How to do? As I said, Garrett ranking technique. So that working should be done, but from that we get to know which is most preferred place, which is least preferred place. That is our alternate hypothesis. So always alternate hypothesis come from the data, but null hypothesis is simple to identify. Okay. Tell me, saving details of 100 male and 100 female employees are available. So male employees, how much they save on an average, female employees on an average, how much they save, but from 100 they have got the data. This is the data. If you see here, there are 2 things here. 1, savings, 2, male and female. This is the first scenario, only marks, but same marks, boys how much, girls how much. So can you see 2 variables actually come here, correct? But anyway, what's the data? I mean, what do you think is the hypothesis? No significant difference in savings of male and female. Both male and female save similarly. The saving habit is same, etc. Now, alternate hypothesis always comes from the data. We don't have here. There is a significant difference is what it says. Let's suppose average savings of male, 100 male is 10,000 per month. Average savings of female employees are, let's say, per month 15,000. Now we can write alternate. What is the alternate hypothesis? Female employees save more than male. Female are better in savings than male, something like that. Now that becomes our inference if null hypothesis disproven. Now here we don't have complete data, but based on data we should write alternate hypothesis. Okay. Number of hours spent at library by first class student, second class, pass class, failed students are available. So we have taken all first class student, found from them how many hours they spend in library, take an average, same the second class, etc. So let's say first class students average they spend, let's say 20 hours in a week, second class students, let's say 14 hours in a week, pass class students, let's say 8 hours, failed students, let's say 25 hours. Anything, data can be anything. I can't be biased in saying failed student don't spend any time, correct? It can be any direction. Okay. What is the null hypothesis? No significant difference in library time spent by all category students. Categories here based on result. So no difference. All of them spend, the time spent everyone is same, similar. That is null hypothesis. Alternate hypothesis comes from what? Data. Now here I deliberately gave something, but whichever is higher. So these students spend more time in the library, this category. So opposite of that. So if you spend more time in the library, you may pass. But what I have given, if you spend more time in the library, you will fail. I think all of us know. In fact, very recently it happened. I saw a statement, a thing written on T-shirt, which said, "I was born intelligent, education ruined me." Maybe possible. So having studied so much, maybe they would have failed also, who knows. But from the data, we should take the alternate hypothesis. Hypothesis. Ma'am, you can elaborate also. You can explain and elaborate. You can elaborate. And that is the further interpretation which inference is this. Now, there's an inference, but why is the next part of analysis. No, you should. In fact, definitely, I mean, unless we do that, it doesn't. What I'm just mentioning what is the inference, but definitely it has to be further analyzed. Why spending so much hours people failed? Definitely, unless we do that, we're not getting what we need for our research. Definitely we need to do that, yes. Stop, this is just the inference. Why, what, all that probing has to be done. That's actually what, keeping in mind we should actually have the data in our question. You should, ma'am. Okay. Now, let's say 100 employees were given training. Employee number 1, 2, 3, 4, 5, 6, something like this. So, like this 100 employees or some employees were given training. But before training, what was the production they made? Production before training, so let's say before, after. So let's say A was producing, employee 1, before training 10 units in a day, now it is 12 units, 14 units, 18 units, something like this. Now this is the data for some people, some employees. What is the null hypothesis in this case? There is no significant difference in production before and after the training, meaning training was not effective. The statement is what we should be able to identify. No difference means what, sir? Training was not effective. What's the alternate hypothesis? For that you should need the data. In this case, from what I have given, there is a significant difference, and what is the difference you can see? After training it is more, means training was effective. But suppose instead of 12, 18, etc., let's say this is 8, 6, etc. Suppose, then training was detrimental. Null hypothesis is no significant difference, but alternate means training was not effective. Alternate could be positive side or negative side. That depends on data. So always remember, alternate hypothesis comes from data. Null hypothesis, we have the liberty, no difference. So whether we have data or not doesn't matter. But alternate hypothesis comes from the data. Okay. Simple but interesting. Now, what's the classification over here? Male, female. Totally 360 people are interviewed, of which 180 male, 180 female. And who watched what genre of movie? Comedy, thriller, romance, action, drama. All this would have been part of our descriptive analytics, descriptive analysis. What do we do in descriptive analysis? For all the data, we make tables, charts. Remember, after that only we can come to inferential. That's the reason I said it's a sequence. Now, this is there. Now, never ever, just looking at it, make inference. It should begin with hypothesis. After testing only, we should make inference. What is the hypothesis or null hypothesis in this case? We have gender, genre, movie genre. So here, the third category, what I gave you under null hypothesis, I gave 3 categories. No significant difference between sample and population, no significant difference between 2 groups, no significant relationship between 2 variables. So there is no difference between genre and, no significant relation between gender and genre. Means who watches what movie doesn't depend on gender. What genre of movie watch has nothing to do with gender. No relation. Now, how to test, all that I'll mention later. But in case it is proven, okay. Disproven, if it is proven to be false, then alternate hypothesis we should make from the table. If you see, female prefer to watch comedy, thriller, romantic movies, while male prefer to watch action, drama movies. Something like that. This is very imaginary data, but it could be anything. And inference need be one single statement or one single word. It can be definitely an elaboration. So, no significant relation between gender and genre. Alternate hypothesis is male prefer to watch so and so kind of movie, female prefer to watch so and so kind of movie. That is alternate hypothesis. In 5 minutes, 5-10 minutes. Okay, I'll just give 2 more scenarios. You tell me. Ma'am, inference is need not, as I said, one statement or one word. Inference is what you are finding out. This is the finding. Definitely, yes, possible. Actually, yeah, thriller. Yes, definitely that's an inference. So, thriller movies are preferred by both male and female. Yes, very much. From this, what all we can draw, ma'am, everything is a part of inference. Yes. So, it need not be just one single statement. It's not statements, it's what we are finding out from this data. Yeah. All definitely yes, all that is our finding. Ma'am, inference is nothing but what we find. Absolutely, absolutely. Only null hypothesis, no difference or relation. Once it is disproven, whatever we can find out is all our inference. So it can be 10 statements, 10 points. Yes, all that is our inference. Okay. Just one last case. Okay. Just this and one more. Okay. Some disease, 70 people were given some medicine, 70 people were given water. So many were cured, so many were not cured. This is the data we have. What is the hypothesis? So again I repeat, please don't ever looking at table may come to any conclusion, draw inference. Hypothesis, testing, then only inference. What's the null hypothesis, sir? No relation between type of treatment and cure. No relation. That's the null hypothesis, no relation. So whenever 2 variables, simple, always keep in mind no relationship. So what treatment was given, what is the outcome, no relation. How to test, I will mention that in the next session. But once it is tested, if proven, okay. Disproven, Then from this we should come up with the inference. Now, the imaginary data, what can you find out from this? Sir, can you identify this? What can you find out? Yeah, so water is more effective than vaccine, something like that. Something, I mean, this is imaginary data. But water was better than this. Some such inference can be drawn. Or medicine was not effective. All that is a statement we can make. Now, these are some examples of how to make hypothesis. But, well, making hypothesis is one part. So, mind you, we have identified the problem, derived objective. The appropriate term is derive objective, because to find solution, what we should find, that is objective. For that objective, keeping that objective, data points, design the tool, administer the tool and collect the data, and this data what we collect, analyze. And this analysis what we have to do, broadly 3 categories or 3 stages I would say. Descriptive, we just describe the data. Inferential, where we draw inference, and this is actually the findings what we want for our objectives. And then predictive. Inferential analysis begins with making hypothesis. For every data point, it may be one variable, more than one variable, whatever. Every data point, if you observe the situation I gave, initially it was only one single variable, then I combined different variables, etc. 1, 2, whatever the variables. Make hypothesis, null, alternate. Alternate hypothesis always comes from the data, it's not something you can think of. Null hypothesis is general. Test it, how, what test to apply, we will see that later, and draw inference. If proven, if our null hypothesis is what we test, if that is proven to be true, then no difference, no relation. Proven to be false, what is the alternative? That is our inference. Now, what test to use? How to draw, how to find is it accepted or rejected, right or wrong, how to find. Next session we will discuss that. As a part of the test, one test is correlation. But honestly, correlation has not much role to play in our inference, not hardly much. So, I was not sure why it was wanted, but anyway, I will show what to do. With Excel, 2 seconds, and today manually, do I know how to do correlation regression? Definitely not necessary, correct? We have packages. Excel is good. SPSS will be learning. So, how to interpret that is what we need. And 2, predictive analytics, cross-sectional, time series is about building model. And again I repeat, if you are doing PhD level research, without that your research is incomplete. All these our postgraduate students do. So, what is that? So, it has to lead to that, and that model building is based on concept of regression. So, I will just give the foundations as required for that. But first, what test to use when, and how to find should we reject or accept. Let's see. So, please take a break. Can we get back in 5 minutes and continue?